James Webb Space Telescope continues to make headlines, not only for its remarkable discoveries of distant galaxies and enigmatic black holes at the far reaches of the universe, but also for its recent focus on something truly extraordinary. This time, it has captured something mind-blowing. We are all familiar with the breathtaking phenomenon known as the northern and southern lights, or auroras, caused by charged particles from the sun colliding with molecules in Earth's atmosphere. Typically, these dazzling displays are limited to high latitudes, as our planet's magnetosphere channels these particles towards the poles. However, auroras have also been observed on other celestial bodies within our solar system, including Jupiter, Saturn, and even the active moons in Io and Enceladus. In these cases, the light shows are likely triggered by charged solar particles bombarding these objects. Now brace yourselves for this remarkable revelation. Utilizing the NASA James Webb Space Telescope, astronomers have discovered the presence of an aurora around a failed star, scientifically known as a brown dwarf, named W1935. Situated over 40 light-years away from Earth, this brown dwarf has left scientists perplexed because there are no nearby stars that could supply the charged particles necessary to ignite this stunning display. Brown dwarfs, which are larger than gas giant planets but smaller than stars, form from the collapse of gas and dust clouds, similar to how stars are born. Consequently, many brown dwarfs, including W1935, are often found in isolation. These objects earn the somewhat unfair moniker, failed stars, because they lack the necessary mass to sustain the fusion of hydrogen into helium, which powers stars during their main sequence lifespan. The presence of a potential aurora around W1935 was indicated by infrared and solar radiation emissions detected by the James Webb Space Telescope, particularly in relation to methane. When methane emissions are observed on Jupiter and Saturn, they result from the heating of their atmospheres as charged particles travel along magnetic field lines and collide with atmospheric particles, generating auroras. Consequently, the research team suggests that a similar mechanism may be at play with this solitary brown dwarf. While methane was expected, the surprising twist emerged when the observations revealed that instead of absorbing light, the methane emitted light. The methane emitted a glowing light, leaving one of the scientists baffled. Their initial reaction was one of bewilderment.
Why would methane be emitted from this object? Since the brown dwarf lacks an external solar wind that could likely trigger its aurora, the research team theorizes that there might be an internal process occurring within the brown dwarf, providing energy to its atmosphere. Another possibility is that interstellar plasma is colliding with W1935, or the brown dwarf may not be entirely isolated and could be receiving particles from a nearby active moon. Of course, there could be other explanations as well. Further observations will shed light on the exact cause of this phenomenon. Auroras have been previously used to explain peculiar characteristics of brown dwarfs, such as radio emissions from warmer examples of these failed stars. However, the observations made by the James Webb Space Telescope on W1935 marked the first time methane emissions from a brown dwarf have been detected, indicating the presence of an aurora. This remarkable discovery allows us to delve into the chemistry behind these processes and unravel the similarities or differences of auroral phenomena beyond our solar system. And that's not all the peculiarities the telescope has witnessed in the early days of 2024. It has also observed galaxies that resemble pickles, leaving astronomers astounded. For a long time, astronomers assumed the galaxies in the early universe would resemble orbs or disks, much like those in the present-day universe. However, the latest images captured by the Webb telescope have shattered this belief. It turns out that not only were baby galaxies not orb-like, but they are even more peculiar than scientists anticipated. Yes, the newborn galaxies from the early universe bear a striking resemblance to bananas. This surprising conclusion emerged after a group of astronomers re-evaluated images of 4,000 newborn galaxies observed by Webb during the universe's infancy. If these findings prove to be accurate, it could revolutionize our understanding of the processes governing the formation and expansion of galaxies. Additionally, it holds the potential to provide valuable insights into the mysterious nature of dark matter, an elusive and invisible substance believed to constitute a significant portion of the universe. Interestingly, many astronomers are skeptical of these findings, despite the fact that they build upon hints from earlier observations made by the Hubble telescope, which also suggested that the earliest galaxies had pickle-like shapes. Dr. Alan Dressler of the Carnegie Observatories, who played a crucial role in developing the James Webb Space Telescope, expresses his skepticism regarding these results. Although he wasn't directly involved in this particular observation, he maintains some reservations about the findings, emphasizing the difficulty of making precise measurements, especially for distant, small, and faint galaxies. The team of scientists conducted a statistical analysis of the two-dimensional projections of galaxies on the sky to investigate their three-dimensional shapes. If the initial galaxies were spherical or disc-shaped with random orientations in space, astronomers would expect to occasionally observe their complete faces, appearing round and circular when observed through telescopes.
However, the observations did not align with this expectation. Instead, astronomers found a prevalence of shapes resembling cigars and bananas. Dr. Panya, the lead author of the study, noted that these galaxies appeared very linear, with some exhibiting multiple bright clumps arranged like pearls on a necklace. These elongated galaxies, which make up around 80% of the galaxies in the Cosmic Evolution Early Release Science Sample, are rare in the present-day universe, but are believed to be the progenitors of galaxies like the Milky Way. This suggests that our own galaxy may have undergone a similar phase in the past, exhibiting a cigar or surfboard-like morphology. In the modern universe, galaxies are generally categorized into two basic forms: elliptical clouds and flat disk-like structures, such as our Milky Way. However, the earliest newborn galaxies did not initially resemble these familiar forms. Back in 1926, Edwin Hubble developed the Hubble sequence, which classified galaxies into three categories based on their appearance: ellipticals, lenticulars, and spirals. In 2010, a team of European astronomers analyzed data from the Hubble Space Telescope to create a census of galaxy types and shapes spanning from the early universe to the present. The study included 116 local galaxies and 148 distant galaxies. Surprisingly, the results showed that the Hubble sequence 6 billion years ago differed significantly from today's sequence. At that time, peculiar galaxies were more abundant, indicating that these peculiar galaxies had transformed into normal spirals over the past 6 billion years. This suggests that collisions and mergers played a role in shaping galaxies, even after it was believed that galaxy mergers had significantly decreased 8 billion years ago. The study also highlighted that spiral galaxies are relatively young compared to other types of galaxies. Fast forward to the present, and the James Webb Space Telescope continues to challenge our understanding of the universe.
Its latest finding further disrupts the standard model of cosmology, which suggests that galaxies evolved over time from amorphous structures formed from primordial hydrogen and helium. According to this model, galactic collisions and mergers were common in the early universe, leading to the formation of disks and spirals. Consequently, spiral galaxies were expected to be more common in the local universe, but rare in the early universe. However, a team of scientists utilized data from the Cosmic Evolution Early Release Science Survey, gathered by the James Webb Space Telescope. They identified 873 galaxies, with redshifts between 0.5 and 4, corresponding to galaxies that are between 5 billion and 12 billion years old. Out of these galaxies, 216 were classified as spirals. While some misclassifications may have occurred, 108 of the galaxies were unanimously classified as spirals. When the team analyzed the galaxies by redshift, they discovered that the fraction of spirals decreased as they went further into the past. However, the fraction of spirals at redshifts above z equals to 3, around 11.5 billion years ago, was much higher than expected. When the observations were calibrated, it was determined that approximately 1/5 of the galaxies at z equals 3 were spiral galaxies. This indicates that these very early galaxies had already evolved into spiral shapes less than 2 billion years after the Big Bang, leaving little time for mergers and collisions to be the primary cause. In other words, while mergers and collisions do play a role in the formation of spiral galaxies, there are likely other factors at play as well. In a nutshell, the James Webb Space Telescope has once again amazed us, this time by uncovering an aurora surrounding a brown dwarf devoid of neighboring stars. It's a captivating discovery that challenges our understanding of these isolated celestial objects and opens up new avenues for exploration. If you enjoyed the video, leave a thumbs up, share your thoughts in the comments section, and subscribe to the channel where the universe unfolds.